All right. Well, we have to keep it spicy.
Cool.
So do we want data to be
Korea.
Do we want the data to be available or not? I mean, let's start there.
Who cares?
I think everyone knows who you guys are. I mean, you just introduced yourself. I think everyone knows Illia. We can skip the
You missed
intros,
a lot
right?
of talks.
You've been living under a rock if you don't know who these folks are. Okay, let's start with basics. What is data availability and why does it matter? Do you want to kick us off, Nick?
Sure. So you can think of data availability as data publishing, and why it matters is that if you're trying to build a decentralized system, it needs to be verifiable by the people that are like participating in it, right? And so if you don't know what the inputs to the system are, then you can't actually verify that the actual outputs are actually legit. So for a roll-up, you need to make sure the transaction data was published so that other people can verify it for you, essentially. So data availability is data publishing, not data storage. A lot of people think that it's storing the data so that you can retrieve it later. It's very different. It's more like, a good analogy is that it's more like a newspaper where people subscribe to a newspaper and read a newspaper to have the most recent events, important things that matter to them, so they know what they are. And data storage is more like a library where it's like, oh, well, this isn't some important information and I want to store it away so that maybe in the future I want to know what it is. But clearly, a newspaper and a library are like very, very different things, and people tend to conflate them in blockchains with data availability.
Yeah, maybe to add that every layer one, every blockchain does that by default, because as somebody produces a block, you want to make sure that first all the other validators have it available, and then you want to make sure that over time, kind of any other participant who wants to validate that the blockchain is correct are able to synchronize and get that data. And so as you go more modular, you want this, now kind of decomposed from where you settle. So you now have external data availability, but it's kind of embedded part of any blockchain, from Bitcoin to rollups, from app chains to layer ones.
I want to linger on this point for just another moment because it's so important, and it is one of the most common misconceptions about this kind of problem space. What makes data availability so hard? And maybe another way of phrasing this question is why doesn't Filecoin solve data availability for us? You kind of began touching on this with your analogy of the newspaper versus the library, but why does Filecoin not just solve this so we can all just go home?
Yeah, so the hard part about data availability, which I talked about in my talk just before this, is that if you want to scale blockchain systems, but you want them to remain verifiable, you need a way to verify that the data was published without having to download all of it. Because essentially, the default way that every blockchain solves data availability is that every node has to just download all the data. And the problem is, as you increase the amount of data that you're trying to process, the number of transactions you're trying to process, then every node would have to download that much more data. So now, if you had, let's say, 1 billion people using the same blockchain, no single node would be able to, or maybe Google, if you're Google or something, you'd be able to download all that data every time there's a new block. But the average person wouldn't be able to. And so if you want to make it so that users or participants that don't have as much resources are able to verify the chain, you need to find a scheme that allows them to verify the data was available, but without having to download all of it. And so the solution, it was long, actually the Bitcoin, in the Bitcoin community, people have been talking about this idea for a while, but they thought that there wasn't really a solution. And then, naively, it doesn't sound like there would be. It sounds kind of like, well, how can you know that data was published or is available without downloading all of it? And the solution was basically invented in 2018, which is called data availability sampling. So it basically, you encode the data in sort of a redundant way, and then you sample over the data randomly, and then that gives you a statistical guarantee that all that data is actually published and available to anyone who wants to see it, but you only have to download a tiny, tiny fraction of that data. So that enables you to have massive blocks while still, I can verify on my smartphone that the block is valid from the context of all the data is published.
Thank you. That was really, really helpful to me and hopefully to the audience. I'm going to torture your metaphor here a little bit because I think metaphors are really useful and really important. So to use the newspaper versus the library analogy, the naive solution, which is what all blockchains have done since the beginning, is like, so everyone has to download everything. This is kind of like your newspaper gets bigger every day, right? There's more accumulated data. So imagine if your New York Times, is 1 inch thick this week and it's 2 inches thick and then 3 inches thick, and you reach a point where that's not practical anymore, and you need to begin storing the old data, which is to say the old articles, the old issues of that in a library somewhere, right? You with me so far? Torturing the metaphor. But then ideally you still need, as you were saying, some mechanism that you can verify that indeed those things are in the library and you can access them when and if you need to. Is that in line with your setting?
Yeah, that's pretty good.
Can I be spicy for a second? So Filecoin is literally the method of the way they validate the data is stored is by data availability sampling. I mean, it's using a little bit different, like through ZK mechanics, but they constantly randomly sampling the data is stored. So to your question, why is Filecoin not a solution is still there?
I guess this is a question for Nick.
I honestly don't know enough about Filecoin's protocol design, but I know that the solution, the problem that it's designed to solve is basically, I want to pay someone a certain amount of money to store this data for a certain amount of time so I can recall it at any moment. I'm also trying to think, I need to think more about this.
Yeah, I mean, I think it's really just about optimization for a different use case, right? And especially because for like blockchains, you do want to run some type of node replication, indexers, all of this infrastructure around. And Filecoin indeed is more about storing, and like the retrieval is kind of done very differently. So you don't have as like kind of the same streaming capabilities, but in theory, you can actually build a data availability system on top of it.
You probably could with the same set of primitives, but it is a different product designed to solve a different problem.
Exactly.
In the form it's in today. There's a million things here I want to dive into, including data availability sampling. But before we go super deep, just to, again, kind of still in the introductory phase, rollups are a really important hot topic. We're all talking about them. There's been a lot of rollup content here. I don't know that we need to talk about what is a rollup. I think people hopefully understand that by now. But can we talk a little bit about why data availability is a problem for rollups? And again, we weren't talking about data availability 3 or 4 years ago, right? Like these two topics have kind of emerged in tandem. We've landed on rollups as like the de facto scaling solution, at least in the Ethereum ecosystem, right? So what is the connection between rollups and data availability?
Well, I'll actually maybe start because we were talking about data availability in 2018 and 19. That's why this methods actually came up in the first place, is because as you wanted to scale any network, right? I mean, this challenge that like you don't want everybody to download the whole block, and at some point they cannot validate it, they cannot even download the data. And so especially, as we see, like however big the machine is that validates the blockchain, people will find a way to saturate it, as we've seen in past few weeks.
There's a name for that. I mean, you can call it Illia's law, for lack of a better word, but
yeah. And so kind of the discussion back in 18 and 19 is like, how do we scale blockchain? It was, we need to have parallel compute, we need to have parallel, transaction processing, but also we need to have a way to have transaction data as well in parallel. And that's where, sharding was discussed as a solution, and in a way, lazy ledger back there started as well from very similar kind of initial, like principles. And you have Polkadot design, which in a way is like very similar, like roll-up architecture, but it's all kind of all within the same idea. It's like, hey, we need multiple parallel, set of nodes, compute that can be receiving their own transaction, can be executing them, and then there should be some way to revalidate everything and settle everything. And Near took a sharding approach, meaning like as a user, you don't know what's going on under the hood, and it can scale under that. But we literally in the paper in 2018 had data availability section because you kind of need the same problem, right? You cannot have validators syncing all of the data across all of the shards. You need to have guarantees around that. And then rollups kind of emerged as an alternative solution, which just opened up the design space for like different execution environments. But as you are running kind of this parallel compute, you need to now settle to Ethereum, which means you need to publish all your data and you need to publish the proof or the outcome of execution. And now everybody can, read from this. Now, Ethereum has a limitation. It's a single machine, so it gets overwhelmed. And so
Like it gets attacked by cats and dogs and the meme coin of
like
the
whatever
week.
the meme coin of the jour. And so how do we actually scale beyond that is where I guess Celestia started the movement of modularity and kind of decomposing the data availability out of settlement and making that as a separate component. So
I think for a long time, like people sharding and a lot of the scaling technology was all about, well, there's a limit to how many transactions any one sort of state machine or like blockchain computer and state it can handle, essentially. So we're going to need some kind of method of horizontal scaling so there can be multiple blockchain computers running in parallel. And now then the problem becomes, okay, well then how do you have these blockchain computers be able to interoperate with each other and verify each other, and then how do you have them share security so that there's not heterogeneous security or like a sort of a trusted bridge between them. And I think that that problem was sharding was the best idea for a while, but then when rollups came around, it was like, wow, you could spin up a fully new blockchain computer essentially and have its execution be provable. And that way it can, interoperate with other computers, other blockchain computers, and you can have this horizontal scaling. It's kind of like the best horizontal scaling technology that we have come up with, essentially. And it gives you all this flexibility over defining your own execution environment. And the way that they can share security is by sharing a common data availability layer. So rollups and data availability are kind of like complements of each other. And you need to scale DA to have rollups be able to scale horizontally.
Yeah, they're two sides of the same coin. That's a good point. And just for the sake of completeness, as we're looking back at the how this kind of scaling landscape has evolved over the years, why not Plasma? Why not state channels? Why did we land on rollups as the best solution? Because we've all been around for a few years. I remember when we were up here talking about how excited we were about Plasma, and of course maybe Plasma will come back. Vitalik's been talking about it again lately. But what advantages do rollups have over those? I think it is related to data availability.
Yeah, I mean, the challenges with all those designs were that either it's only a limited set of participants that can actually have this, and then you also need to, those participants needed to have locked their assets kind of in those transactions, right? So state channels was a great example, and we see this with Bitcoin, right? You need to lock a bunch of capital to be able to kind of live in that environment. It's, not just capital intensive, it's also kind of very complex. You need to find the counterparties. And then Plasma, it never had a design that actually wasn't broken because of, indeed, lack of data availability guarantees. And kind of the exit game was always there was always a way to trick the exit game. I remember we were interviewing actually Georgios from Loom on our whiteboard series, and we figured out a way to break their exit game on the whiteboard, which was a little bit unfortunate. But it's also was a good example to show, right? And so I was actually at the hackathon in 2019 when the Plasma group, which now known as Optimism, came up.
For folks who haven't been around so long, yeah, right. Optimism, formerly known as the Plasma group.
Yeah,
I didn't actually know that lore.
I was judging that track, and they came up with a universal Plasma, which what rollup became, optimistic rollups became. And so it was really just an extension of that. Okay, well, how do we ensure the guarantee of the exit game? Well, you need to publish all the data and have a fraud proof or some type of proof that kind of this set of transaction end up with this result.
That was the key insight, right? That's what led us to rollups. This is kind of what I was getting at with my question earlier. The superpower of a rollup is that all of the transaction data is there, maybe in a compressed format, for anyone to see, and so anyone can independently verify it, independently spin up a state machine, or even replace a sequencer that goes rogue or something. Yeah, so data availability is important. Okay. Illia, you guys announced at Near pretty recently that you're now thinking of data availability as a product, so to speak. Near wasn't originally a data availability chain, although of course all blockchains provide data availability, as we were talking about earlier. Can you talk a little bit about that decision?
Yeah, so as I said, Near blockchain we've been thinking about data availability from the start, because as we scale the network, we need a way to kind of make sure that even if one shard of validators went completely rogue, there's a way to, validate that, and which means you need to have other validators to be able to recover the data, recover the blocks, and revalidate it in some form. And so the Near from the start has an approach which is using erasure coding, and where it's weaved into the consensus as people produce blocks. They are, erasure code them, send them around to everybody else. And so there is a kind of set of guarantees that as consensus progresses, that all the data is available, and you can have a very small subset of validators to recover any of the block data in the network. And so that always was there. That's how Near is actually able to continue scaling. And so the benefit is we actually have something that, for each of the independent shards, we have about 4 megabytes per block of data available. It's very cheap. Our cold data pretty much for Ethereum developers is extremely cheap. And you're able to pretty much store things in it and then leverage Near smart contracts to actually enforce various conditions. And we have a light client and ZK-proof light client that you can now use on other chains to also validate this. And so those pieces, if you cook them a little bit with those guys who sit in the room here, you actually get a really good data availability solution that, including actually scales over time and adds more capacity as more shards added. So for example, Near has in past 2 weeks went from 4 shards to 6 shards, adding 8 megabytes per second more of data availability capacity to the network.
So I guess question for Nick is like, how do you guys think about capacity, right? How much data availability is enough data availability? What happens if you run out and need to...
Maybe before that,
Sure.
Do we want, given we have a Proto dank sharding in the title?
No, I mean, okay. Yeah, I'm definitely going to cover that. Okay. Let's just keep it spicy. Another way to, I can also phrase this by saying, if I am building a layer 2 today and I'm looking for a data availability solution, why would I choose Celestia or Near, respectively?
That's a great question. So I think the data availability is there's a few different things. One is obviously cost and capacity of the underlying layer, and I think Near as well as Celestia employ different techniques essentially to ensure the scalability of the DA capacity. But there's a bunch of other important considerations. So one is sort of the security model and the verifiability. So I would say the gold standard is essentially data availability sampling and having actual light nodes that users can run to verify that the data is available themselves. And I think so far Celestia is the only protocol with that built and live. I think Avail is close, and hopefully Ethereum will launch that in the future with full dank sharding. In addition to that, there's a bunch of other things where as a developer, if you're building a rollup, you kind of want specific kinds of interfaces or sort of a construction of those blocks that makes it easier for you to build rollups on top of it, post data, read data, as well as even if, let's say you're like a ZK rollup, being able to prove certain things over the history of those blocks that I think if you're a monolithic chain where you're retroactively sort of like saying, okay, now we're going to be a DA layer, you don't have the advantage of building all those different components into the protocol from the beginning. And I think Celestia and probably Avail and certain other protocols that started from the beginning saying, this is the problem we want to solve, have sort of like those features baked in, and I think makes them superior from like the developer experience and like functionality perspective.
Any response?
Rebuttal? Are we going
This is a debate, remember?
It's a debate, right.
Rebuttal now.
Okay, yeah. Well, so, I mean, there's like few things to talk about, right? But I'll start from the end. I think the big benefit of actually having a full smart contract chain that is doing data availability is that you can go beyond just DA. And DA is a really good substrate for building other features. For example, you're able to finalize quicker because now you have DA posted, you're able to integrate, potentially partial execution of these transactions and settle them faster. Use that, for example, for bridging. Use it for communication with other chains or applications. you have an opportunity to have, for example, preconditions and postconditions on DA to build features like, shared inclusion, like bundling of transactions across multiple chains, and potentially like a shared sequencer type thing, because you have already consensus, you have DA guarantees, and you can actually build all this. And so like the idea is like it's way more programmable environment where you can build kind of interesting ways to interact between multiple rollups, and or for specific rollup kind of add extra conditions. Now, going to a more like validation, I think there's definitely kind of principal interest for everyone to validate everything. I think like as values, like we have that as Cypherpunk. The challenge is we have never seen this in reality, right? Ethereum has a light client, and none of the wallets validate it. There's now a ZK light clients for Ethereum, and none of the wallets integrated it. And to be clear, like I'm all for having all that infrastructure, and we should have it. And you do need it when you are kind of connecting different chains with each other. Again, that's why we do have a light client. It's been in production since 21 for the light client bridge with Ethereum. Now we have ZK proof on top of it with succinct, which allows to have a kind of DA, for example, proven on Ethereum for validation. But I think like we need a new approach that is not heavyweight kind of, and by heavyweight I mean even like 100 kilobyte validation is too much for the end user phone, for example, when you are like spinning up your device. And then the other thing is that I think that it's important to also understand from which perspective are you looking at, right? So if we're talking about Ethereum settlement, right, the guarantees you want to have is that Ethereum is able to access data on Celestia, and Ethereum is not able to actually do data availability sampling, right? And so you do need some way, like kind of a proving way to go back to Ethereum and prove that data is available when the guarantees and kind of settlement happening. And so for that, there's various methods employed, and I think you guys are building as well some bridge to Ethereum, right, to ensure that. But that's actually a more important, like how good, stable, and robust consensus, how easy it is to prove it to Ethereum, and that your validators are actually posting this data and validating it. So I would say like there's kind of a spectrum of things, and like there's benefits of both. You can also, the benefit with actually rollups, you can post data on multiple places. You don't need to pick one or another, and you can kind of gather benefits from different ecosystems as well by leveraging, for example, these extra features that are being built around a DA. Want to add anything?
Well, I just add, I think it's a fair point about having programmability on the DA layer, and we at Celestia actually think that in like the end game of the modular stack is going to be that you're going to want the data availability layer to be as pure as possible, because if you add execution and state to the DA layer, that's basically an added overhead to every single rollup that is using it. And so Celestia was designed specifically to minimize execution. There's no smart contracts or any, like, this minimal amount of state on Celestia, so that it's as light and as flexible and as thin of a layer as possible. We think that makes Celestia a more desirable sort of like universal DA layer in the end game. And it's also more similar to like a Bitcoin essentially, where it can be this very, like, if you don't have the execution, you don't have to sort of mess around with that part, and you don't we don't have to ever upgrade anything. The only changes Celestia will do is to increase its throughput of DA and maybe certain like interface changes to make the developer experience better. But like it can be this very stable foundation on which to build the rest of the stack. And we think that optimizing for that minimalism and stability is like super, super important.
Yeah, I think this is one of the beautiful things about the space today, is that there's such a wide menu of options. And like, if, as I said before, if you're someone looking to become a customer of a data availability layer, like you really have radically different options, whether you're looking at Near or Ethereum or Celestia or Avail or other projects. And this is one of the benefits of the modular thesis as well, is mixing and matching, and rather than just being stuck with a single.
It's the modular stack working as it's supposed to.
100%. Okay, I promised we would talk about Proto dank sharding. It's in the title of the talk, so let's make sure we spend a few minutes on that. So for anyone who has been living under a rock, there was a very large, important Ethereum network upgrade that happened a few days ago called Denkun. That included, I think it's 4844, right? Maybe I have the number wrong. I always get these EIP numbers wrong. Yeah. So this is the very first step for Ethereum in the direction of increasing data availability for things like rollups. It introduced this concept of data blobs. When you guys want to explain a little bit more about what Proto dank sharding is and why it's a good thing for the ecosystem?
Yeah, Proto dank sharding is the first step towards full dank sharding, which is a full data availability sampling protocol on Ethereum. And essentially what it did is it opened up a new sort of like lane of block space that is just blob space essentially. So there's no execution over this data. It's just like people or rollups basically can post data to Ethereum, and it has its own separate fee market and everything else like that. So it sort of like expanded and kind of made it modularized Ethereum slightly to have like a data availability layer component to it. And yeah, it's important because obviously most of the L2s in that are live are using Ethereum. When you post as call data, which is mixed in with the rest of like the Ethereum like fee market, it's really expensive. And so this enables people to use Ethereum, hopefully like a cheaper mode of using Ethereum as a DA layer. And that way you can have like stronger security essentially as a rollup.
Yeah, thank you for that background. So this was the most significant upgrade to Ethereum since the merge. Having worked on Ethereum upgrades in the past, I can say this is no small feat. So just massive shout out to everyone who did work on that Denkun upgrade. It was, yeah, seriously, credit where credit is due. It was a huge success, and it was purely as an observer, just watching the price drop instantly of the rollup transactions was really incredible. Although they've begun to spike on some of the layer twos like Base. I guess the obvious question is like, how does it change the landscape of data availability? Like, does it change how you guys are thinking about or approaching being a data availability layer, or you guys, Illia, at Near?
Well, I mean, just for some numbers, right? They added 16 blobs of 128 kilobytes per blob. And this is every 12 seconds, right? So this is somewhere like, 140 kilobytes per second of throughput, which definitely, a massive improvement over, I think, like 80 kilobytes or even
12 seconds.
Yeah, every 12 seconds. So like, it's definitely kind of
it's like a 10x or something, but it's also cheaper because the data is ephemeral.
Yeah. But as we've seen also that happened, I think yesterday, is somebody launched inscriptions on top of it as
this is bound to happen to every
would. Yeah.
Yeah, just wait long. We don't have inscriptions on Spacemesh yet, but I'm sure it'll happen. Has it happened to you
guys? It's happened on Celestia too, yeah.
I've East Seoul Hackathon, Spacemesh inscriptions. Bring that network down. Sorry.
We're offering bounties.
Test it out.
It's a good problem to have.
Yeah, but that kind of spiked the prices for everyone as far as I saw yesterday. But I think generally, obviously, more data block space is good. And so we've seen that happening. People are switching to this. But at the same time, it's definitely nowhere near the scale and capability that people actually want to. And that's why, in many ways, the kind of prices for layer 2s actually went up, because people are like, oh, cool, we can transact more.
It reminds me a lot of this phenomenon where, you have highways that get crowded, right? And so what does the government do? They build another lane on the highway. And then as soon as they do that, there's more cars and more demand for cars, and it fills up again. So I feel like we're going to be in this kind of, it's going to continue for a while because there's more demand than there's availability.
Well, that's what I was saying. Like any singular kind of state, for data or for execution, right, will get filled in. And so you do need a way to continuously increasing the size. And so that's why they are working on dank sharding, which will have ability to scale that up, although it's still a fixed amount. But generally, yeah, I think the kind of it's great because it actually promotes more people doing this. And so now we're going to have more and more people launching layer 2s. They see a ton of now also incentive because like, Base is making, I think like $15 million per, I forget what period. Per what? $20 million per month on the sequencer fees right now. And they're paying now is Proto dank sharding maybe like $1 million a month in ETH fees. So there's like a ton of incentive now for people to launch more rollups, which will need a lot more data availability and a lot of more tooling around that and a lot more kind of other, things. For example, I talked about chain signatures to abstract all this because we're going to have, 1 million chains now. And as a user, you'll not be able to navigate that.
All right, we are just about out of time. We need more time availability. Sorry. But any final thoughts, final words, things on your projects or on data availability, like what people should take home with them from this panel?
I think, as Illia said, well, where Celestia wants to go, like the mission that Celestia started out with was we want to make it as easy for people to deploy a blockchain as it is to deploy a smart contract. And I think we're making important strides there. And where we want to go, like the end game, my talk before this is titled, the path to 1 million rollups. And really, if we're going to get to a million rollups, which I think is the end game of sort of like Web3 or like the initial end game, we're going to need a ton of data availability. So there's just so much work to be done on, optimizing these systems and scaling them. And it's exciting to have all these different teams like Near and EigenDA and Avail and everyone like, committing to this and trying to help scale it because it's going to take a village because this is a huge undertaking. Like, to get to where we want to go, it's like the more people working on it, the better.
Let's keep it modular.
All right, that's a great note to end on. Thank you guys very much.
Thanks, Lane.